Hello, and today we're going to be looking at 6.1 volume using cross sections. I will do the 6.1 in two parts. The first part will talk about cross sections and disk method. The second part will talk about washer method. Okay, so the first section we're talking about cross sections. So if you picture this graph we have in front of us, and we took a slice, like a cross section, and we took the area of that cross section. What we want to do is now take the integral from b to a, from a to b of that integral with respect to x of that cross section area, and that'll give us the volume of that shape. Okay, so let's take a look at example 1. Has to do with a pyramid 3 meters high and a square base that is 3 meters on each side. The cross section of the pyramid perpendicular to the altitude x meters down from the vertex is a square m meters on the side. So they're talking about each of the cross sections will be a square. Okay, and I put the diagram here just to make it a little more friendly for us. So we got each of these cross sections is going to be a square. Okay, so for the problem, the integral will be from 0 to 3, okay, because the height was 3. So we'll have from 0 to 3, and we have the area, and the area of each of these squares, right? Area of a square is x squared. So that means we would have our area function would be x squared, and then we would do with respect to x. Okay, so that's how we would set this up. So next thing we would do is we would integrate this. So when we integrate x squared, that would be x cubed over 3, so 1/3 x cubed. And then we would evaluate the bounds from 0 to 3. So we would have 1/3 of 3 cubed minus 1/3 of 0 cubed, but that's just going to be 0. Okay, so what are we left with? 1/3 of 27. So it would be 9 meters cubed. Okay, and that would be the answer for that one. Okay, so that's area with cross sections. You would need to know the formula for the area of each cross section, and then you integrate from A to B, and we find the volume that way. Okay, let's take a look at the disk method, a very popular method of finding the volume. The idea is we have some kind of shape, okay, and then to figure out the volume of the shape, each of the cross sections are going to be circles. Okay, so for example, let's do this problem. Region between the curve y equals square root of x. So that means we would have square root of x is half parabola that opens like this. X is between 0 and 4. Okay, so let's have 4 be here, 0 be here. And the x-axis, so it's the region between the curve, and when x is between 0 and 4, and the x-axis is revolved about the x-axis. Okay, so it's this region then. Okay, so that's the region that's going to get revolved around the x-axis. We want to find its volume. Okay, so that means because this is going to get revolved, you could picture some kind of shape. There's going to be some kind of right, and if you picture the cross sections, each of the cross sections are going to be circles, right? Area of a circle is pi r squared. Okay, so that's where this formula really comes from, right? We have pi, the r of x, that's our radius function. Okay, so the radius function in this case is going to be the square root of x, and then we just have our bounds from 0 to 4. So that means we're ready to set this up. Okay, so we have integral from 0 to 4 pi, radius function is the square root of x. Don't forget to square it, and it's with respect to x. Okay, so when we square the square root, they cancel each other. Right, so let's do that. That means we have this. So we have integral pi x dx. We can pull the pi out. So I'll pull the pi out. And so I'm going to integrate this. So when I do that, I'll have that becomes 1/2 x squared, correct? So 1/2 x squared. I'm going to evaluate from 4 to 0. Okay. Okay, so now I could plug in my bounds. So my 1/2 and pi, I'm going to put that here, pi over 2. And then for this, I'll put the 4 in the square it, so 4 squared minus 0 squared. Okay, so 4 squared is 16. 0 squared is 0. And so pi over 2 times 16, the 2 and the 16 would cross cancel, so we're left with 8 pi. Okay, so that would be the final answer. Okay, let's take a look at another example. Find the volume of the solid generated by revolving the region bounded by y equals square root of x and the lines y equals 1, x equals 4 about the line y equals 1. Okay, so let's graph this. Okay, square root of x, that's our typical half parabola. The lines y equals 1. Okay, so let's say y equals 1 is here, so that would be x equals 4. Okay, x equals 4, let's say is here. Okay, so it's this region in here. Okay, so it's this region, and we're going to be rotating it about the line y equals 1, so we're spinning it about this line. Okay, so that means we'll end up with something that will go like that. We'll have this rotation going on. Okay, so when we go to do this, we will have our integral will be from, where do we have it from? So we'll go to, this will stop here at 1, right? Because this is at 1. X is 1 as well, right? Square root of 1 is 1. So this is going to go from 1 to 4. Okay. And now how do we figure out what this radius function will be? Well, the way we figure out the radius function is you picture the square root of x function. Right, the square root of x is here. And to get the radius, we take away this gap, the 1. Right, that's going to be the amount of the radius. So you have the square root of x. The square root of x is typically the whole thing, right, from the x-axis all the way up to the curve. But now because we got the y equals 1, we take that part away. Right, so our radius function will be square root of x minus 1. Okay, so when we go to set this up, we have 1 to 4 of pi times square root of x minus 1 squared dx. Okay, so what we could do is pull the pi outside. What we want to do is expand on this binomial. So we'll FOIL that out. Square root of x minus 1 times square root of x minus 1. That'll give us x minus 2 square root of x plus 1. Okay, now we get integrated. So we have here 1/2 x squared minus, we have, this would be x to the 1/2 when we integrate that. That would be what? Let's see, x to the 1/2. So we would get x to the 3/2 over 3/2. So that means we have 2 times over 3/2 is the same as multiplying by 2/3. Integrating the 1, we get x. I integrated already. Okay, so this is what we have. If you want to clean this up a little bit, we have 1/2 x squared minus 4/3 x to the 3/2 plus x. Okay, so now we can plug in the 4, plug in the 1, and then we subtract. Okay, so let's do that. Pi 1/2 of 4 squared minus 4/3 of 4 to the 3/2 plus 4. Okay, minus 1/2 of 1 squared minus 4/3 of 1 to the 3/2 plus 1. And keep in mind we have the pi and multiply everything. Okay, so now it's just arithmetic, right? We have 4 squared is 16, half of 16. Half of 16 would be 8. Now here we have the square root of 4 is 2. 2 cubed is 8. Plus 4. 1 squared is 1, so we have 1/2. Square root of 1 is 1. Cube it is 1. We have minus 4/3 plus 1. Okay, so anything we can combine here? Let's see. So far we have 8 plus 4, that's 12. And then inside here, when we distribute the minus, we have a minus 1. Okay, so let me write that out a little bit. We have 8 and the 4 is 12 minus 4 times 8, 32 over 3 minus 1/2 minus 4/3 plus 1. Okay, so what do we end up with? Let's continue it a little bit more. We have, we said that was a minus 1, so we have 11 minus 32 over 3. Distribute the minus, we have minus 1/2 plus 4/3. The negative 32/3 plus 4/3, that would be negative 28/3. Minus 1/2. Okay, so we need a common denominator. Looks like it's going to be 6. Okay, so if we have a denominator of 6, that would make this 66 over 6 minus 56 over 6 minus 3 over 6. Okay, 66 minus 56 is 10. 10 minus 3 is 7. So we have 7, 6. So 7 pi over 6. Okay, and that would be the final answer. Alright, let's take a look at the volume when we rotate about the y-axis. Okay, so when it's about the y-axis, as you guys could imagine, the function must be in terms of x. X equals in terms of y, right? So your function will be in terms of y, so you'll have x equals, right? And then your bounds will be from c to d. Okay, those are going to be, you're playing off of the y-axis. Okay. Find the volume of the solid generated by revolving the region between the y-axis and the curve x equals 2 over y, where y is between 1 and 4, about the y-axis. Okay, so let's get the curve down for this. The curve is 2 over y. And to get the graph of it, you can just make a simple xy table if you're not familiar with this. You know that y is going to be between 1 and 4. So you can start with the y column. Make y 1, 2, 3, 4. And you know your function, x equals 2 over y. So we're looking to get the x values. Plug in the y's. So when y is 1, we have 2 over 1. So we have 2. When y is 2, we get 2 over 2, which reduces to 1. When y is 3, we get 2 over 3, which will just be 2 over 3. And when y is 4, we get 2 over 4, which is 1/2. Okay, so we get the order points, order pairs, and that means this will look like, let's take a look. So we have 2, 1, okay, 2, 1, 1, 2, 2/3, 3, so like that, and then 1/2, 4. will be the curve. Okay, and we're going to integrate this from 1 to 4, so we already know that we got 1 here, we got 4 here, and we're spinning this about the y-axis. Okay, so this is going to spin around. Something like that, if you want to picture it. Okay, so that means we could set this up from 1 to 4, pi, and the function was 2 over y, so 2 over y squared dy. Okay, very straightforward. All we gotta do now is expand on the 2 over y, and then we can continue. Okay, so we bring the pi outside. 2 over y squared would be 4 over y squared dy. We could even bring the 4 outside, combine it with the pi, so we have 4 pi. So we have 1 over y squared. So remember that that's going to be y to the negative 2. Right, so we integrate that, add a power, and that means we would have negative 1, and then divide by negative 1. So this ends up becoming negative 1 over y. And then we go from 1 to 4. Okay, so let's plug those in. So we have 4 pi negative 1 over 4 minus negative 1 over 1 Okay, so what does this give us? We have 4 pi negative 1/4. Now here this negative 1 over 1 is negative 1, minus a negative 1 is plus 1. And so now if we distribute the 4 pi times negative 1/4 plus 4 pi times 1. Okay, so the 4's here will cancel. This will be negative pi plus 4 pi. So negative 1 pi plus 4 pi, that would be positive 3 pi. Okay, and that would be the volume. Okay. Let's take a look at another example. Find the volume of the solid generated by revolving the region between the parabola x equals y squared plus 1 and the line x equals 3 about the line x equals 3. Okay, so for x equals y squared plus 1, that would be the parabola opening up sideways. It has an x-intercept of 1. It's opening to the right. And the region between the parabola and the line x equals 3. Okay, so let's do x equals 3. Vertical line. So it's this region. And we're going to spin that about the line x equals 3. So we'll have another one of these going on the other side. Like this. Maybe something almost like a football-like shape. Okay, so how do we describe our radius function, right? So it's still rotating about a vertical line, right? Just like it was rotating about the y-axis before. So we're still going to do in terms of y's, x equals in terms of y's. So those are ready for us. We got x equals y squared plus 1, x equals 3. So to figure out the radius, so our radius is going to be in here from, let's say, like from here to here. Right? To get that radius, we take our 3, right, and we subtract the y squared plus 1. Right, that would give us what that radius is going to be. So if we do 3 minus y squared plus 1, right, that'll give us that radius, the outer edge of that parabola. Okay. So if we were to simplify that, 3 minus y squared minus 1, 3 minus 1, that's 2. So 2 minus y squared. That would be our radius function. Okay, so 2 minus y squared. Okay, the only thing left to do is figure out what our bounds are going to be, because we haven't talked about it either. The bounds we have to figure out are going to be between here and here. So where are those two the same? Okay, so we just set the two functions equal to one another. Y squared plus 1 equals 3. If we subtract 1, both sides, we get y squared equals 2. And we can solve this using the square root, both sides. So y equals plus or minus square root 2. Okay. So we have square root 2 here and negative square root 2 here. Okay, so we're ready to integrate them. Okay, we have negative square root 2 to square root 2 pi, put in a radius function, 2 minus y squared with respect to y. Okay, we can pull out the pi. Expand on this squared binomial, so we have 2 minus y squared times 2 minus y squared. FOIL that out. That gives us 4 minus 4y squared plus y to the 4th. With respect to y. Okay. And now we can integrate this. So we have pi. 4 becomes 4y minus the y squared becomes y cubed divided by 3. So this will be 4 thirds y cubed plus 1/5 y to the 5th. And then we would go from negative square root 2 to square root 2. And now we could plug in our bounds. Okay, so let's take a look at the next part. We have pi. Plug in the square root 2. So 4 square root 2 minus 4/3 square root 2 cubed plus 1/5 square root 2 to the 5th minus 4 times negative square root 2 minus 4/3 times negative square root 2 cubed plus 1/5 times negative square root 2 to the 5th. Okay. So we have our pi, 4 square root 2. We're going to evaluate in here. We have square root 2 cubed. The square root 2 times square root 2 would be 2. 2 times the 4 would be 8. So we have 8/3 square root 2 plus square root 2 to the 5th. That means we have 5 of them. Square root 2 times square root 2 is 2. We get another 2, that's 4. That means we have 4/5 square root 2. And then we have minus negative 4 square root 2. And then here, this is almost the identical operation we did earlier, except we have a negative. So that's going to make this a plus, right? Because it's going to be negative times a negative. So it'll be plus 8/3 square root 2. And then here, this will be a negative times a positive, so that'll be negative 4/5 square root 2. So we have pi. The negative we have to distribute here. That's going to make that, let me do that real quick here. Minus a negative is plus. Minus a plus is a minus. And then minus a minus is plus. Okay, so what does that give us? That means we have 4 square root 2 and 4 square root 2. That's 8 square root 2. Negative 8/3 and negative 8/3. That's negative 16/3 square root 2. And then 4/5 plus 4/5, that would be 8/5 square root 2. Okay, next we've got a common denominator. So it looks like between the 3 and the 5 would be 15. And we get the 15 here. That's times 3, so that'll be 8 times 3, that would be 24. For this one we have 15, that's 3 times 5, so 16 times 5, that would be 80. And then for the 8, we have 8 times 15, that would be 120. 120 over 15 square root 2. Okay, so we have 120 minus 80, that's 40. 40 plus 24, that's 64. So 64 square root 2 over 15, and we got the pi. So we could clean that up and just say that this is going to be 64 pi square root 2 over 15. Okay, and that would be the final answer. Alright, we'll continue with part 2. Any questions, just bring it up in class. Have a good day, have a good night. We'll see you soon.